would you maybe want to say that AF is equal to AF prime plus a value x? Prove x is 0.
Okay, that's one way to do it. Shall we do it that way, or shall we do it the way that I thought of? Which is kind of the same, but it's not really the same. We can do either, we can do both. We can fairly vote like a democracy. We can vote whether or not we want to leave the EU or whether we want to stay, and stuff. Okay, let's do it this way. So, first of all, FB is equal to AB minus AF. That's true, right? Yes? Now, why am I doing that? Why am I going to take FB and replace it with that? So in this, I'm planning to take FB, replace it by AB minus AF. Okay, kind of, not really, but like, yeah, what's the motivation for?
You're lessening the number of variables.
Yeah, so AB is a constant. I mean, AB doesn't depend on F and on F prime. And the only thing that's left is AF, but AF is already on top, so you kind of just, you're introducing something that's already there, so you're making at least this side simpler. Cool? So you have AF over AB minus AF. Same thing on the other side. You have AF prime over AB minus F prime B. Right, yeah, F prime A. Now let's do AF prime. Okay, and now what do? So we cross multiply. On the left hand side we have AF times AB minus AF times AF prime. On the other side we have AF prime times AB minus AF prime times AF. And what happens, that cancels on each side. We're left with that. And then we can divide by AB because it's non-zero. If it was 0, then B and A would actually be the same point. You can divide by AB. So AF is equal to AF prime. Cool? So AF is equal to AF prime, which means this distance here has to be 0. So F is equal to F prime. Cool. We're all good. We could all like do this. Like if I erased everything and just did that, you could do it. Just like immediately. Like you don't need to think about it. Just good. I am such a good teacher. Such a good teacher. Okay. Why did no one like say yes you are? Or anything like yeah. Just no. Wow. You guys are great students. Okay. So that's how you prove Kocheva's theorem, well, at least one way to prove the other direction. So we've proven that if that's true, then that's true. And we've proven that if that's true, then that's true. So we've proven both directions, and that is Cheva's theorem. And how am I doing for time? Oh, okay, so I've got another like 3 hours. Good. Okay. Now we're going to use Cheva's theorem in a few cases. We've done it in the case of medians. Okay, so let's take a random triangle. Now, a CVN is a line which goes through that point. So it goes through that point, intersects the other side somewhere. So you can imagine there's lots of CVNs. You can just take any line and you've got a CVN. But there are some special lines. So one of them we already did was when you take the line and it goes through the midpoint. That's a median. Okay, what are some other special lines? Yeah. Perpendicular bisectors, like the one that I couldn't prove to you last time, that was actually that one. Okay. So that's another special Cevian. And so now using Chever's theorem, we can prove that these three are actually concurrent. Okay, so A, B, C, what shall I call these other three? Okay, fine. D, E, F it is. D, E, F. Okay. Now, we've got some ratios of sides to kind of figure out. So in a similar way to the proof of Chever's theorem, we're not going to take these ratios directly, but we're going to group them differently, and we're going to like take each ratio, prove that it's equal to another ratio, and then those three just cancel. Cool. So this over here that we have to prove is equal to 1. That is equal to AF over AE times BD over BF times CE over CD. Okay, so I've just written it differently, putting all the stuff that is around point A together and B and C together. And we're going to prove that each of these is equal to something else. So, first of all, so we want to prove that's equal to 1. AF over AE is equal to AC over AB. Cool. So the reason why this is cool is because we've taken this ratio and we've written it entirely in terms of the sides of the triangle. So we can probably rotate it and stuff will cancel and we'll go on like happy and rich and like all the good stuff. Now, how do we actually prove that? This is very important. When you're proving that three lines are concurrent, you have to make sure that you don't accidentally actually assume that they go through the same point. So in your logic, you have to make sure you don't assume that. But yeah, AF over AE is equal to AC over AB. I'll give you a hint, similar triangles. So find a pair of similar triangles which gives you that. Yeah?
Can you draw a line from F to E?
From F to E, okay, yeah, sure.
So then prove that AFE is similar to C, what? To ABC.
AFE, but AFE will be ACB. Yeah, so same thing. Okay, so that's another way of doing it. Okay, so how are we going to prove that that is... So they have a common angle there. So we just need to prove that that angle is the same as that one, right? Because if we prove that that is the same as that one, we can do the same thing to prove that that one is the same as that one, because it's just reflected. And that's how we'll show that that is similar to that now. So, how do we get that this angle, AFE, is equal to ACB?
Exterior angle of cyclic quad.
Which cyclic quad?
Cyclic quad CEFB.
Okay, so CEFB is cyclic. Why? Not you. Why is it cyclic? Yeah.
Because angle CEB is equal to angle CFB because they're from the same course.
Cool. So that angle is equal to that, which means that is cyclic. And then external angle here is equal, external angle there is equal to internal angle on this side. Cool? Everyone good? By the way, what's the center of this circle that goes through CEFB? What is the center? Right? No, the center of this circle, which goes through there.
In center.
No.
On CB circumference.
No. So it definitely has to do with CB because it's CB and FE.
Isn't CB the diameter?
Yes, CB is the diameter because you've got those right angles there, which means the center will be the midpoint of CB. Cool. So the center of the circle is the midpoint